Good morning, afternoon, everyone. This is the final lesson in Introduction to Statistics. This is the end of the spring 2020 semester, but these videos should be good from here on out as the subject matter doesn't really change. The StatCrunch part may change. We do use StatCrunch. They do update their software from time to time, but as it happens in the future, I will add subclips to these. So chapter 12, what were we looking at in chapter 12? Chapter 12 was on 3 or more populations and we were looking at the proportion parameter. Chapter 13, which we're going to do today, 13.1 is on 3 or more populations. And here we're going to be doing a means test. The parameter will be the mean. And this method is called analysis of variance. And the reason why I capitalized the first 2 letters of the first and last word is this is abbreviated ANOVA, analysis of variance. Okay? And we're going to be doing the one-way test. As a reminder, variance, the parameter symbol is sigma squared. And we know what sigma is. Sigma is standard deviation for a population. And that's what variance is, standard deviation squared. This hypothesis test, this is a test of equality. Of the mean of 3 or more populations. Okay. So we're going to say we have K populations. Let us have K populations. What that gives us is H naught is this. Mu1 equals mu2 equals mu3 equals ... up to mu K for K different populations. They're all different. And the alternate hypothesis is at least one mean is different. Okay. That's how the test goes. All the other steps say the same. Let's just discuss the requirements of the ANOVA test. So requirements for ANOVA. Like I said, K different populations. And we're going to have one sample group from each. The groups or the populations have no overlap. Or they are independent. And when I mean no overlap, no relationship at all. Okay. We always want, for these hypothesis tests, the populations are normally distributed. And we know if that's not given, we have to check the probability plot or the QQ plot. For linearity, or a straight line, and we want to check box plots for no outliers. And that is all if we don't know if the populations are normally distributed. Many problems will tell you that they are. And the final requirement we have, populations have approximately the same variance. Variance. And the way we're going to do this is we are going to look at the largest variance, our largest standard deviation, and it needs to be less than 2 times the smallest standard deviation. So to do that, we will go to stats, summary stats, and we'll look at standard deviation and compare. Once the requirements have been met, we can go into our test. Our test is in StatCrunch, and it's stats ANOVA one way. Now I have already saved the data table in there. If you search for Jones FA ANOVA in datasets, we can speed this up, and let's do that right now. So we're going to look for data sets right here. And we're going to search for Jones Hefe ANOVA. And there we go. So these data sets come from the problems in the lecture notes. I'm going to pull the lecture notes back up, but that's now the data is already in there. Note to do this. When we look at stats, ANOVA one way. There is no option for summary stats. It wants the columns of data. Data needs to be entered in columns by group. By the sample or population. We don't have any other option. Okay, so let's go back here and let's look at the problems we're going to work on. All the other steps stay the same. And the first problem we're going to take a look at is on what page? What is this? Page 156. This is the money problem. And so we have, we've got financial, energy, and utility stocks. And the stock analysts wondered whether the mean rate of return differed over the past 5 years. Do they differ in mean rates of return? That black pen is dead. Toss it. Got a fresh one. Let's make our table real quick for the complete list in the lecture notes. We've got 10.76, 15.05, 17.01, 5.07. I don't need to read them to you. I'm reading directly off the screen or the lecture notes that you have access to. And finally, utilities. Okay. So those are our groups. There are 8 from each category. And the question is, are the mean rates of return different at the 0.05 level of significance? So pause that if you need to write them down. First off, we're going to check for if we can use the ANOVA test. So first off, the problem does not indicate normal distribution. And we also need to check, do the variances match? So let's go over to StatCrunch, take a look at what we got. Let's do box plots on these. Financial, energy, and utilities. There are no outliers. And then we'll check our QQ plot. That one looks pretty straight. That one looks even straighter. And that one looks pretty straight. The smallest correlation statistic is 0.984. QQ plots look good. And finally, we're going to check our summary stats. Summary stats columns. We're going to look at financial, energy, and utilities, and we're going to do the standard deviation. So sigma of F, sigma of E, sigma of S. This is 5.12, 4.87, and 4.53. Is the largest less than twice the smallest? That's how it works in the words. Is the largest less than twice the smallest? The largest one is 5.12. The smallest is 4.53. So let's multiply that by 2. And we get 9.06. How do 5.12 and 9.06 compare? 5.102 is less than 9.06. So this meets the requirements for variance are met as well. There's no reason to think that financial, energy, and utility stocks have any relationship with each other. So they're independent. There's 3 different samples, so we have 3 or more. We meet the requirements for the test. So steps of the test. Let's do the test. Step 1, identify H0 and HA. H0 is the mean of the financial equals the mean of the energy equals the mean of the utilities. The alternate hypothesis is at least one mean differs. The problem gave us alpha. It said 0.05 level of significance. Next, we go to stats, ANOVA, one way. Close that. Stats, ANOVA, one way. And we're just gonna click compute. And fstat is the one we want. .077. The p-value is 0.1502. We will bring our level of significance down and compare. Our p-value is larger. So step 4 is make a decision time. The p-val is too large, the null's in charge, which means the null isn't going anywhere. Do not reject H0. Do not support HA. HA was at least one of the means differs. There is insufficient evidence to support the claim that the 5-year mean rate of return from the 3 stock sectors differs. That table shows some other things. SS, see right there? The first problem actually asks you to compute it by hand, and I'm going to show you how to do it. SS stands for sum of squares. MS is mean of squares. And it'll show you how to get the test. This MS is the stuff. MS is what we'll calculate in Problem 1. And I'll show you how to do it. Okay. That's our first problem. Let's come back over to the lecture notes and take a look at the next one. It's on the next page. And it's this one on discrimination in car buying. Notice in the last section, we had 8 samples, or 8 in each sample here. But evenness or even sample sizes is not a requirement. As we can see in the new problem. So this is what this problem is about. This is on page 157 of our lecture notes. And it's, is there gender racial discrimination in car sales? So this is back from the 1991 Harvard Law Review. So it's important to note that this document is 30 years old. Hopefully stuff has changed by then. Because when you look at it, you start to see, when we go through the numbers, you're like, yeah, there's some discrimination going on, clearly. They wanted to see if there was discrimination, so they put together a team. There were 15 white males, 5 white females, 5. There were 4 black males, 7 black females. And they all were asked to get an initial offer price, on the same car. The 31 individuals were made to appear as similar as possible. So maybe they all wear business suits or something like that. They all drove up in similar looking vehicles. When they said their jobs, they all worked in similarly paying fields. And they wanted to see what the initial offer price was. Because initial offer price minus the cost of the car is the profit to the dealership. And the profit to the car salesman generally makes money off of sales. So the data collected is the profit. And I'm not going to copy down the lecture notes. So see the lecture, there's a lot of fields there. See the lecture notes for the numbers. You can see it in this video as well. They're right there. Do note it says use alpha equals 0.05 level of significance. So let's check this. I have that data right here. Let's check our QQ plots, see what we come up with. Did they actually say whether or not they were normally distributed? I think it's actually fair to assume they're normally distributed. We are talking about people. But let's see what the plots say. Nice straight line there. Fairly straight line there. Fairly straight line there. Fairly straight line there. All the correlation statistics are high. 0.982, 0.982, 0.96, 0.984. 0.96 is the lowest, and it's still pretty good. Let's check the box plots for outliers. And I don't see any outliers, but notice how this box plot looks. Look at how the white female and white male are way over here to the left, and the black male and black female are way over here to the right. In fact, the black females look like they're getting screwed the most, at least back in 1991. I'd be curious to see what it is today. So it looks like there's discrimination. More on race than gender, although it looks like there's some discrimination in gender between black males and females. The white males and females tend to be in the same region. In fact, it looks like white females are getting the best deals. Let's do our test. We got stats, ANOVA, one way. And we'll compute it. So I've got the figures there. Let's go through our 5 steps. Step 1, identify your hypotheses. H0 is, there's 4 groups, so mu1 equals mu2 equals mu3 equals mu4. HA, at least one mean is different. Either paying more or paying less. Alpha was given to us, it was 0.05. And we can see from StatCrunch, our F stat is 61.36. And the p-value is less than 0.001. Compared to alpha, it's a lot lower. Decision. The p-val is too low, reject the hoe. Reject H0 or H0, support HA. I skipped a step. Shame on me. Let's do that, finish the test. We'll go back and do the step. Shame on me. The conclusion is we're supporting HA. There's sufficient evidence to support the claim. And the claim was that there is gender racial discrimination in car sales. Gender racial discrimination claim. I worded my sentence poorly. In car sales. What step did I skip? What did I not do? I actually need to check the variances, don't I? Those are independent groups for sure, assuming that none of these people were married or anything like that. So let's check our summary stats on these. And we're looking at standard deviation. So sigma WM, sigma WF, sigma BM, sigma BF. White male was 226.7. White female was 157.1. I apparently didn't write these down in the order that are listed. I'm just picking categories. So the lowest and the highest is there. What we need to check is 241.5 less than 2 times 157.1. Should be 314.2. Yep. Yes. So the ANOVA requirements were met. Okay. I want to look at a couple problems in the homework for you. Let's take a look at problems number 1 and number 3. There's only 8 problems. The reason why I want to walk you through number 1 is that it will want you to do everything by hand, and there's no real reason you're ever going to do this in reality. So I just want to walk you through how to do it. So this is homework for 13.1, problem number 1. And here they want to calculate the mean squares and F-test statistic. So I'm going to write down what we have here. And what they give us, I will write in black. And what we calculate, I'll do in other colors. So this is some squares. DF is degrees of freedom. And then they want mean squares and F-stat. And we need to fill in here A, B, C, D, and E. So I'm just labeling them. A you're just adding up the call. So mine was 493. I'm going to add it to 4495. $49.88. And the same thing with this one. And that one I can do in my head. 21 plus 4 is doable in my head. On C and D, divide the sum of squares by the DF. So C, I'm going to have 493 divided by 4. On D, I'm going to have 4495 divided by 21. And they want 3 decimal places. So I will go to 3 decimal places. And finally, for E, divide C by D. $0.576. Okay, let me enter that in here. That's it. Okay, so number 1 looks scary because you haven't seen it before. This shows you how to do it. Let's take a look at number 3. Pause this if you need this up longer. Okay. So number 3 is on highway safety. And the Highway Safety Institute conducts experiments in which cars are crashed into a fixed barrier at 40 miles per hour. In the Institute's 40-mile-per-hour offset test, 40% of the total width of each vehicle strikes a barrier on the driver's side. So they make the car hit the barrier with the same amount hitting the car and the barrier. The barrier's deformable face is made of aluminum honeycomb, which makes the forces in the test similar to those involved in a frontal offset crash between 2 vehicles of the same weight, each going just less than 40 miles an hour. This is all a bunch of science they did, figure this out. You are in the market to buy a family car and you want to know if the mean head injury resulting from this offset crash is the same for large family cars, passenger vehicles, or passenger vans, and mid-size utility vehicles, SUVs. The data in the accompanying table was collected from the Institute. Complete parts A through D. Part A is identify the null and alternate hypothesis. The 3 means are equal. Mu of SUV has to equal mu of the van, has to equal mu of the car. That's H naught. And HA, one is different. So which one says that here? A and B both have this. In fact, A, B, and C all have the same H naught. H on C, they have them ranked. On B, it says at least one is different. On A, it says all means are different. The test is just to see if one of them is different. So this one should be the one that's slightly different. Part B, it tells us the normal probability plots indicate that the sample data comes from normal population. Good, we don't have to do that work ourselves. Are the requirements met? Well, let's check the standard deviations. Let's load the data in StatCrunch. So we'll do stats, summary stats, columns, and we'll look at the standard deviation. So the cars is 200.3. The van is 186.97, which is 187. And the SUV is 127.2. So here's my highest one. Here's my lowest. Is 200.3 less than 2 times 127.2. We multiply that, what is that, 254.4? Yep. And 200.3 is less than that, so yes, it meets the requirements. Let's check the other ones though. The largest sample standard deviation is more than twice the smallest. That's not true. No, because the samples are not independent. Yes, they are. They're all different types of vehicles. The populations are not normally distributed. No, they tell us they're normal populations. And C, the requirements are met. So for me, it's C. Yours might be different. Now it says, let's do the work. So we're going to go stats, ANOVA, one way. I'm going to write them down both now because I'm sure it's going to ask me for the p-value. So f-stat to 3 decimal places, 0.388. And it wants my p-value to 4 decimal places. Ooh, I wanted all of them. Tricksy. That is bigger than alpha equals 0.01. So we do not reject H naught, do not support HA. There's insufficient evidence to reject the null hypothesis. P-value is too large. Thus, we cannot conclude that the means are different. Draw box plots. I'm kind of curious what the means are. Let's take a look. Looks like that passenger van one's not a whole lot larger, but larger. Looks like the SUVs have the smaller one. And what was this data on? The mean head injury. I wonder how they calculate mean head injury. Huh. Oh, box plots. It wants box plots. So I've got SUV on top, vans, and family cars. For me, so I've got SUVs on top, vans, and cars. B and C have that. A could work if we just change the order. Let's see what it looks like though. B, my graph over here, the SUV has the largest low end and the smallest high end. Vans looks about right. Cars on B looks like it goes farther to the right. If I compare it to C, vans goes farthest to the right, then cars. That's how mine looks. These middle lines look about like mine. Mine looks like C. And that's how these problems work. All right. That concludes the lessons. Since this is a unique semester, I will be deciding how I'm going to be doing the testing probably this weekend, maybe Monday. And I will have a video on the practice exam and talk about the test next week. Okay. Peace. I hope you've enjoyed this lecture series. I wish we had more time to chat together in class and have fun. But what you gonna do?